All right. It looks like we're not going to get Josh today. Not sure if we'll get Sage or not. So why don't we just get started? All right. Not too much going on that's new here. Casey, there's this increased beast parse buffer size to 64K. I imagine that's not super complicated.
Correct.
Any significant improvement?
I'm not sure yet. This came out of some performance work that Marcus was doing, and he noticed that our reads were really small out of the front end sockets, and so this should help. It hasn't been validated yet, though.
Okay, cool. All right, let's see. Other one, there was someone actually went back and like was working on Rados Bench, which is fantastic. I don't know who this is. I didn't even look that closely at what they're doing, but shining some light in there is probably good. So, yay. Let's see. Then there was this. The only other one that merged this past week was Sage's 64K Alex size PR. So that merged, and it looked pretty good. I think it should be fine. Niha, I wanted to mention, I think both of your other PRs are still sitting out there. Is it time to close those? I don't know if you're trying to talk or not, but you're muted. Oh, she's gone. Must have lost her. So let's see. Lots of updates this week. Igor updated his new, smaller version of his work for letting Blue Store kind of intelligently pick where files are going to live. So that's really good.
Can you hear me now, Mark?
Yes. Hello.
Sorry, I was having trouble with my network. Yes, we can close those.
Cool. Yeah. So yep. So Igor's thing is being worked on, and that's really good. They'll let us not waste the DB space quite as much as we currently do. Let's see. Sam's PR is here for expanding LTT and G trace points. I think either Adam or maybe Igor are going to review that along with the FIO objects, stuff object store backend work. This read data portion of pushing objects in batch. I don't remember what the comments were on that one. Just that keep them safe for reviewing that. But I think there was some concern about it, though, if I remember right. Sage, I think you looked at that, right? That it was, I think it just needed some justification as to why.
Kifu and I both looked. It's sort of trading one set of assumptions and optimizing for that for a different set. I think we really just need to expose a read sparse type method to the object store interface. Behave in all cases.
Sure. Okay, so let's see. This async read for replicated backend, Radek reviewed that and has some concerns about it, specifically CPU usage. And he said it looked kind of similar to one that I think was out there before. So yeah, I think that was basically his comments on it, that I think he wanted to see more perf results and make sure it wasn't going to cause problems. Let's see, there's more updates to this common finisher one. I think it failed testing, if I remember right, and then it's now in the works again. Adams, I object, got a review from Josh. Yay, thank you, Josh, even though you're not here. and more updates. Auto tuning of the MDS cache memory limit. Got some new updates. Patrick had requested a status update on that one, and it looks like it's still in the works, so being actively worked on. All of Adam's charted work got some updates. Josh had reviewed that previously, but he's still actively working on that. That's good. And then just this distributed data cache, RGW1, just got marked not stale. I think Mark Hogan is maybe, I don't know if he's working on it or if he's looking at it or something. So yeah, that's it for this week. Nothing else too interesting going on here, I don't think. Any other PRs I missed, Sage, or anyone else?
Thing I know about.
All right, cool. Well, then for this week, I guess I have just kind of one thing I wanted to talk about, which is that I started working on a new S3 benchmark about maybe a week or two ago, because I was getting sick of trying to figure out how to find another one that worked well. Apparently FIO now supports S3, which I had no idea about, so that might actually work just fine, but I'd already written this thing, so it works pretty well, and I'm not sure how the FIO plugin actually works for it, so I've been using this. Basically the justification or the motivation for this was to have something that runs really well from the command line, isn't like super heavy or big or crazy, and is fast. There's another one that I had been using previously called getput that was written by Mark Seeger at SUSE, but he's retiring and it's in Python and it's kind of slow. It uses a lot of CPU. So this is in Go. It's reasonably fast. It's not as fast as it probably would be in C++, but it's okay. So it's good enough to showcase a lot of things going on, which is kind of what I wanted. So take a look at it if you're interested. Hopefully it'll be useful.
How easy is it to use? I mean, so if there's examples for using it in the PR or its website or whatever, that'd be great. Or its repo, that'd be awesome. We'll try it.
There is an example in the README. Let me link to it.
Yeah, I got it. It's in the chat. Pretty easy. It's all in the command line.
Yep, that was the goal, is to not require crazy GUIs or other bizarre stuff.
Okay, it's awesome.
So I've got like a Google Doc listed in the thing here. Let me copy it and I'll paste it. And this is, for the past week, I've been running through a bunch of tests just to make sure that, one, this benchmark works well, and then two, just to see if I can find out anything interesting. The motivation for this testing was that on the OSD side, there's been a lot of concern about OMAP and whether or not OMAP might be like ridiculously bad when we're doing big RTW workloads. One of the biggest concerns actually was whether or not like compaction stalls are causing like horrible like client-side latency spikes when doing bucket index work. So that's what I wanted to really look at on NVMe especially, because it shouldn't be a problem. And I did see a lot of client latency spikes, but it wasn't OMAP and it wasn't like compaction stalls and RocksDB on the OSD. It seems to almost entirely be during bucket index resharding, and that we've talked about this on IRC some, but it's really interesting. If you go and look at the max latency tab there, you'll see that there's all of these like latency offsets, maximum latency, that are always offset by like 5 seconds. It's 0 or near 0. It's like really low, well, relatively low, or 5 seconds, or 10 seconds, or 15 seconds, 20 seconds, all the way up to 35 seconds. And this is because I guess when we're doing these operations, these resharding operations, we'll just wait for a 5 second interval, and then if it's not complete, then wait another 5 seconds. Casey had mentioned changing this to be like a back off scheme, which I think totally makes sense. So I might give that a try. It shouldn't be too hard to implement. And I'll submit a PR for it. But probably the bigger fix, right, is I think, Eric, are you thinking of working on something that would let you do writes during resharding? Is that the idea? Or Matt, maybe?
So,
That's my idea, but I'm trying to get someone to type it. But so yeah, go ahead, Eric.
yeah, so it's at the discussion phase right now, trying to work through things. But we don't want to stall everything when resharding occurs. And so some ideas we've talked about are, for example, when resharding is occurring, have a sliding window where certain things are directed towards, certain things which have not been resharded yet are directed towards the old sharding, the old bucket index. Things that have already been things that have already been resharded are directed to the new bucket index, and then there may be a window in there where you can't access it during this as it's sliding through, resharding every one of the bucket indices. So that's kind of the idea. It definitely needs some fleshing out to see what the issues are with it, but that would be nice.
Well, I assume that you can write to both views.
Yeah, maybe in the middle ground, you're writing to both. That's correct. I
don't think there's any need for a blackout. So there'd be a constant overhead during actual resharding, but it would be limited in there, and it would not impose the stalls. We'll talk. And according to Casey, you also found that there was an interesting latency sort of ramp up as leading to the resharding event. This is interesting. So you should get a chance to disclose it. But we've, in response to it, we've proposed that we can, and Casey's going to think she can type it quickly, but if not, we'll hand it off to someone to do it. Move the reshard check out of line entirely, out of the right, and into the bucket info cache. Oh, sorry, the quota cache, which apparently already has a thread that does some summations and could do this.
So what I've been seeing is that, like, when you hit the number of objects required to invoke resharding, right? So like say you've got 100,000 objects in one bucket, right? So as soon as you hit that 100,000 object mark, then it appears that you suffer a reduction in performance and an increased latency for some period of time, followed eventually by a stall, and that seems kind of non-deterministic. Like it's not. I don't have a clear understanding of when exactly the stall happens, but I assume it's based on background work happening or something up until that point, and then it decides to actually do whatever it's doing that causes the stall. And then after that, right, then you'll see the much faster performance now that you've got more shards to work with.
Yeah, there's a background thread running bucket reshards, and it only does one at a time. So the writes will schedule the bucket reshard, and then eventually the background thread will pick it up. But yeah, once you get to the threshold, every single write is going to be trying to schedule the reshard. So I think that's the cost that you're seeing. And the idea is just to move the check on the scheduling for a reshard into the background of the quota thread.
Sure.
Yeah, because doing asynchronously is just a howler, right? So we should just take it out.
Yeah, definitely. And yeah, I have no idea if that's actually what it is or not, but it's. I mean, I can see in like a case where I've already got maybe 8 shards to work with and lots of parallelism, lots of threads, I can go from like 6,000 write IAPs down to like 2,000 once that kicks in.
Yeah.
So
So my theory is that all of the writes on the bucket shards are synchronizing on the one bucket reshard log to write the intent to reshard.
But there's no reason for all of them for us to be racing to do it, nor doing it many times, etc. So
Exactly.
presumably in that other thread that you've got to just like periodically at every thread loop do it, but not, not contend, right?
Yep. Right. It's a quota thread, and it's keeping track of modified buckets. And every 3 minutes or so, it basically sums up stats and writes them back to Rados. And so we can do the reshard checks there.
Sure. You can do it faster than 3 minutes, though, right? Like, presumably, if you did every
but why?
Something.
Why do we want to detect every in this? Why do we want to enter a limiting function on figuring out when to reshard?
It would be useful for me to know not to have that reshard happen when another test starts. Like if I can have it in the testing, just for testing, know that, when we hit this, now I know that reshard is going to happen at least within a certain reasonable timeline of, hitting this object count. That would just make life a little easier if you guys are okay with like a 1 second interval.
Is the 3 minute
It is
configurable? Is it a configuration?
It is, yes. So you
so you can make whatever. Yeah. As long as it's something that you can, it's a configuration parameter, but it in no way is reasonable to make a online operation that works like that. But
maybe I'm confused. I'm just saying, like, if you're checking in that loop, right? Is it checking every 3 minutes, or is it like checking to see the update?
it's checking every 3 minutes. It's looping through to run its consolidation. So when Casey implements this, it will in that same loop check for buckets that need to be resharded.
So right now you're doing it on every single write, and the proposal is to change it from every single write to every 3 minutes.
Well, the proposal is to not the proposal part. There are two parts, but yes, but the proposal is not to do a reshard check in the write path. That's my proposal.
Yep.
But I think that is unambiguously correct. Then
yes.
so separately, then Casey figured out the real problem. So his proposal is that you can solve it by moving it into this to the background consolidation that we're already doing, which is ideal. And it really does sound to me like, your feedback is, okay, for your purposes, I sort of see what you're getting at. You want to have some control in the control plane or in your testing or workflow to know what we're doing. But I think it would be better for us to notify or something like that if you want to get feedback into the workflow than for it to really be effectively synchronous resharding, because nobody should be paying for that. No one should. The resharding should happen when it's ready, and we should reduce its impact by no longer stalling.
Mm-hmm.
And then we should do other things too. You're still going to see when you have that, you're still going to see a different waveform, right? You're going to see you're not going to start seeing the problems that might exist in our test for whether we should we're test for resharding on how fast we're growing the shards. I mean to say. The function that the growth function.
If you delay for 3 minutes, would you end up then with a much larger reshard workload because you haven't started it sooner? If there's like continuous writes happening.
Well, no, but this is a calculus problem, right? I mean, a multiple rates problem, and most workloads aren't going to be characterized by pouring I/O at one bucket. But even if they were, there's no benefit to chasing into the limit to reshard as fast as possible.
And even then there's a delay because it just writes that to the end of the reshard queue saying when this bucket's turn is up, do the reshard. It's only doing the reshard at one bucket at a time. So even then, once it's queued up, it may not happen for a while still. And I forget how often the reshard job runs. Maybe Casey knows offhand.
I haven't looked at it. All I know is that it's doing one bucket reshard at a time. So even entering the
Yeah.
queue, you could wait for some other reshards that are in progress.
I mean, that's totally fine. I guess I was more wondering if putting it off is actually a good behavior, right? Because potentially you
It
have more
is.
work to do.
No, but only in the only on the theory that that it's kind that yes, yeah, only in the sense that that only if you first assume that buckets are always getting larger, and if they are, that it's always the time that it's better to do them now than later. I mean, it's just not. It'll be. You'll have more work. You have more work. The universe is expanding, so there'll always be. There's no better time than later. There's no optimal time to do it.
Especially if you remove the blackout, right?
Right.
That's one thing we see today is the blackout causes some applications poorly written to have problems. So,
Matt, the reason I'm kind of harping on this is because
I get it.
It feels very much like the directory splitting that we had in the OSD, right? In file store, where the more work that you have to do, the bigger you make these, the more impactful they become and the scarier they are, right?
But that's not
that's fell apart anyway. But
that's not. Well, I don't think that's really the case. But one we don't presently shrink. So it's a one-way function to get to reach optimal to reach a new sharding level, and so there's a growth function that we'd like to better optimize too. Right now it just sort of looks for the loading is over a threshold and we're within 90% of it, and then we double or quadruple or something like that. But just some geometric expansion. But doing it earlier could make sense, but doing it earlier, it's never. We don't want to. It doesn't make us want to approach the limit of of the smallest it could be. So as soon as so it's possible that you want to grow to more shards quicker if we're growing faster, or I would direct your attention to the growth function. Starting at a better shard count to begin with is helpful, and then figuring out more rapidly we can eliminate. I would say that your goal will be best served by eliminating multiple reshards in a short interval. So we would like to get to the optimal size faster, especially when it's smaller. We could do that by picking the next size faster. We could make a better guess that we need 18 shards instead of 2 or 3 or whatever it was going to be instead. That would help us.
If I remember right, when I was talking to Casey about this the other day, when that event actually eventually happens is when you decide the number of shards, right? So like by waiting, 5 minutes or 300 seconds or whatever, you've maybe increased how many writes, objects you have now from, you were going to do it at 100. Now you've got like 250,000 objects instead of 100,000 objects. So now you're going to bump up your shard count to, whatever that would end up being, like 5, I guess, instead of 2.
But we can collect more workload. That sounds. I don't know if that's true. I don't remember. I typed this. I don't know if I guess I didn't. This is. I don't remember what this function does. I did the limit check thing. I don't remember what they said.
That I was involved with you on Mark on IRC.
Oh, okay. Yeah, maybe that was you, Eric.
Yeah, and basically when it decides finally to reshard, it'll take the existing number of objects and then figure out what the ideal number of, and then double the existing number of objects, figure out what the ideal number of shards is for that, and then reshard at that level. So you're right, some growth between the decision that we need to reshard and the time when we actually do the reshard might actually increase the number of shards, but actually is good behavior, I think. I think that's what we'd want. Yeah. We don't want to go back to the old one.
No, that's exactly right. But I think the interesting question I have though is like we could take in that short interval we could take additional sample. We could send more information like how fast it's been growing and things like that. But it's a short interval and it may not be representative of the future I/O on this bucket.
I guess what I don't like about it is it feels very much like we have multiple different factors that are kind of influencing how that ends up working out. Like it's not deterministic, right? Like if I have one IO workload and then repeat the same test, depending on when things get scheduled and how long of a delay there is. I may end up with a different number of shards and a different behavior than I would in a previous run. That's what I don't like. I'd very much like if it was very deterministic.
But it is pretty. I think it is deterministic. I'm a little. This is a rat hole.
It's harder to benchmark, but it's better in the real world. That's what it sounds like.
We could have a further discussion about how to make the testing more deterministic. That's legit. We could.
It's
I mean, first of all,
from the standpoint that if you know at what point in the future something is going to get scheduled, and you know how much I/O happened in between, or how many objects end up getting written out, then you know how many shards are going to get created.
But going back to your original suggestion, if you can make the quota consolidator, we can have a short interval like 5 seconds or something, and see whether it's producing high CPU utilization. If it's not, then you'll have your solution. It'll still be the case, however, that at least the scheduling will be pretty instant. It's more or less more effectively immediate. But to be fair, the resharding still takes a period of time, and it'll still take a short period of time before it kicks in. But the biggest source of latency, Casey and Eric pointed out, is how many other buckets need to be resharded. So if your workload is operating on one, that variable is removed.
Yeah. If does it have to be the whole quota loop, or can it just be this piece that could happen more quickly? The check to see if you need to reshard.
There's a couple of different loops. One is for the entire user and all of their buckets, and one is just per bucket that has been modified, and it's this per bucket one that we're adding the reshard check to.
So could you do that outside of the whole user quota check then, like as a separate,
another thread,
either a separate loop
it's the per bucket one that's running every 3 minutes. The other one runs every day, I think.
Oh wow. So right now the check that's done every write, is that that whole other piece, or is it just a smaller subset of it?
It's slightly different, but I would say it's essentially the same thing.
Okay. So if we're doing that every single write right now, we've at least got some, or at least every write when we've hit this condition, I guess. Is that we've kind of got an idea of
the problem is we're doing it every write in order to see if we've hit the condition. So we want to not do that.
Yeah, exactly. I agree.
This is IO, dude.
Yeah. So it's the check that we do every time, and then as soon as we've hit the condition, then further, whatever it is that you guys are doing in that per bucket, workload that gets invoked. Okay. Well, okay, so cool. I think the only other thing I've got in these results so far is that we do significantly better with multiple shards, as you'd expect, with more parallelism. Once you get to the point where you're not doing any kind of dynamic resharding, it's actually, faster than I expected. We're with one NVMe OSD, one RGW, we can put like 8,000 4K objects. We can get like 15 to 16,000, per second. And deletes was about the same as writes. I didn't actually think that RGW would be able to go quite that fast. So that's good.
I think there's. I'm interested in when you find a bunch of things that are in the up at the front of the path, and resharding was worse. We started learning last summer that were more issues that we knew. We fixed a bunch of them, but I'm really glad we caught this, and we can bring it to the fore. We're going to try to escalate, knocking all of these out. But but I think we still want to know what's below that. Then, what the ceiling is in the OSD past that.
Yeah. Both RGW and the OSD were working pretty hard when they're working well. I started doing some wall clock profiling, but ended up getting really sidetracked with this other stuff. I did add a bucket listing test to HS Bench. So now we can look at, once we increase the number of shards, how badly that hurts bucket list times. That'll be good. But yeah, I agree.
But that's really key. But just going back to yesterday, I just wanted to clarify. Are you interested in working on some of the RGW code paths as well as working on the HS Bench, or do you want to throw data over the wall and have us fix things?
My plan right now is basically trying to fix as much low-hanging fruit in general, so as possible before we hit Octopus and possibly any kind of downstream stuff that we get going on. So
well, we want to try to get both non-pause and the reorganized bucket ordering, the lexical order bucket index in by Octopus. They're slightly different things. So if you wanted to work on if you wanted to actually type, you were talking about wanting to type, some caching and stuff like that. If you wanted to type non-pausing, we could help you do it. Otherwise, we'll resource it in the team.
Okay. So one thing that I've got on the OSD side, that as soon as Adam's sharding work lands, then I'm going to try to get my my Blue Store double caching avoidance PR on top of that. I was thinking about trying to do it before that, but I think everyone would rather just wait until the sharding is done. Once we have that sharding, we need to make sure that that's working well and get that in hopefully before Octopus. And I don't know what the plan is going to be for downstream regarding that, but that's going to be a big thing to do. On this side, on the RGW side, I guess the question is, certainly, hopefully by Octopus we can get it in. What about backports, like for downstream? Is the timeline reasonable, or is that something that'd be too big of a change to really backport?
For which things? For what you're speaking of?
Sorry, the things you just mentioned.
I think those are backportable. But I think there's more pressure. There's tougher restrictions on the sharding, right, and the RockCP things from the Rados team.
Yeah, although I'm not. Yeah, I don't know what we'll do there. It's definitely desirable, right? So we'll see.
I mean, our assumption was that these things. I mean, we've been working on this with the bucket changes for a while. We assumed N. We assumed Nautilus. So backporting to that seems to be downstream in that sense. Okay. If someone needs it farther back than that,
None of the things on the RGW side we talked about require format changes, right?
You meaning wire?
There's no change in the way that buckets are. Yeah.
Well, data structures in the wire? I don't think so, but maybe.
If it's just changing the way that RGW processes things, that would be a lot easier to backport, right?
Well, if it changes serialized data structures that are in our CLS protocols, for example, then that's a one-way function for upgrades.
I don't know enough about how all that works to be able to.
But if we change the format of RGB bucket or entry or some other structures that are encoded and shared as operations.
Okay.
But I haven't thought through. I take the fifth. I don't know whether that arises here or not.
Getting non-pausing reshard is going to involve changing CLS RGW. So certainly there it shows up.
Okay.
But I think we should be willing to take it as far back as Nautilus. That'd be my proposal. If people are willing to look to consider that.
What would be so Casey and Matt, what would be kind of the easiest thing to just start off with that could improve something in all of this?
I think that I think the things Casey's already doing. I mean, Casey realized he could get rid of this race to write the intent operation, and he's typing it right now supposedly. So the next thing I think would be to look at look at the non-pausing.
Also the 5-second sleep for.
Oh yeah, that's. Forgive me. That's trivial. Yeah, that's right. But also,
that's what I was thinking is the first step.
if we took a look at the mechanism, at the algorithm being used for picking the larger size, the size of the next reshard. I thought it'd be interesting for someone to at least look at that. If that algorithm is good, or we can improve that has no effect on on formats.
Sure. I mean, a doubling is not horrible, right? Which is what you're basically doing now with some, have slight weirdness with the delay happening. But I mean, that seems about as reasonable as anything to me.
But yeah, I think raising the default sharding and also revisiting the 100,000 objects per shard number, I think would be interesting.
Yeah, that'd be easy to test very quickly on your NVMe setup. We believed that 100,000 objects per shard is unnecessarily small. It's too small basically for NVMe. So if you could quickly test that, that'd be great. That would be great. What happened if you doubled that?
Sure.
But going back to one previous idea, when we write to the reshard log that we want to reshard this bucket, I think we have a timestamp in there. We know that we hit a certain number of average objects per shard, and then when we finally get around to it, we know the new timestamp, and we know how many objects are there now, and that gives us a measure of the time growth of that particular bucket, and that could easily feed in. Although what the right algorithm is, I can't say right now. That could easily feed into whether we double or triple or something along those lines.
Yeah. I was hinting at that. So yeah, that's interesting.
You could do it. You could do something like that. I think it's a question, like you said, Matt, though, of is this like a temporary growth, or do you really expect like long-term growth? And
you don't know. Well, you don't know, but you also will have different information. But each time you restart, you wipe the slate, right? So you could be better responding to the local information we have.
Sure. One thing I just thought of too, which I think I'm going to argue is another reason why you should do it earlier, is that as you're waiting to do the reshard, you're still writing at a slow rate, right? Like if you got, and part of it right now is because we have just one bucket starting out, which is crazy. Or sorry, one shard starting out. But that one shard you can only write like, I think it's like around 700 objects per second too. And every time you double the number of shards, you double the throughput essentially. Up to on this platform, 8,000 is where I top out. So the longer you sit at one shard and two shard and 4 shards or whatever, the longer you're sitting at that,
where did you reach 80% the available throughput?
Let's see. And looking at here for shards. Well, I guess the real problem is that even with 8 shards, as soon as you do dynamic resharding, it just sucks the life out of everything, because going from 8 to 16, basically where you don't have a reshard event, the puts per second went from like 4,000 up to 8,000. So that's if you look at the first tab and look at the one bucket test, it's the graph up in the upper right corner. 8 initial shards was, not getting anywhere close to 16. And that's almost entirely because there just was never a resharding event that happened.
I wonder how much these results are due to the fact that you have all of these shards on the same OSD. I mean, wouldn't you get better parallelism if you had more OSDs, even with the small number of shards?
Me, yeah. Shouldn't you be having more than one? Wait a minute. There is only. I mean, I didn't assume that. If you're an all-in NVMe, there must be more than one OSD.
No, there's one OSD in this test, one NVMe OSD in this test. So it's basically the kind of the simplest configuration that we've got can have. Everything's running on the same host.
Yeah, so it is interesting, Casey. I mean, I know that we talk about in our downstream configurations having more than one OSD per NVMe device.
That's not going to make that big of a difference here, guys. I mean, yeah, we can have multiple OSDs on the NVMe device, but it's not. I don't think that we're going to see significantly better throughput in these tests with more parallelism by doing that.
And you do get more parallelism anyway, right? More shards means more objects, means more PGs, so you're hitting more threads.
We certainly are, yeah.
The primary slowdown, like in this 8 shard case or 4 shard case, is the period at which once you've hit a dynamic resharding event, whatever's happening at that point, if it's these checks, that seems to be potentially doing a number on it, and then the stalls. I mean, those are
okay. Well, let's do one. Here's what I would say: in the 1 week window, what if we do this? What if we take the look, hit all the low hanging fruit?
Sure.
And then retest.
Yeah, definitely. So Casey, changing that check to happen in the other thread, is that something that can be done relatively quickly?
The plan was to try and do it today, and if it's going to be a bigger project, then I'll write up a design for it and share that.
Cool. Yeah, I can try to take a look at the doing a back off on that 5 second value. That's currently hard coded, right?
Yes. Yeah, both the weight and the number of retries is hard coded.
Okay.
So if we reduce the weights, I think we want to retry more.
Yep, definitely. Do we want that configurable, or do we want to just have like a hard-coded back-off scheme that no one changes?
Well, configs would definitely help in tuning it initially, and I think it's worth keeping in if we have it.
Maybe like an upper limit that gets set, like a back off with an upper limit.
Yeah.
That the user can set. Cool. Anything else besides those two?
In terms of low-hanging fruit, I don't think so. I think the non-blocking reshard is the next big thing.
Yeah.
But RGW stand-up starting like right now, so I'm going to head out.
Oh, okay.
Sounds good. I'll follow up with the weight stuff on IRC.
Cool. Sounds good.
Thanks a lot, Mark.
Oh, thank you guys. Appreciate it. Hey, Matt, anything else on the OSD side? I mean, I know that there's always been a lot of concern about, OMAP
Well,
performance.
it's obviously real. I mean, so not being able to. I mean, you've made some important discoveries here, but we know it's real because we know in certain configurations where, or in conditions where we've reached various limits. We've seen extensively in Joule and Luminous at any rate. In specific environments where we ended up with large quote unquote OMAP objects, in other words, large loading of OMAP in a specific key prefix, and interacting with object probably, but also just due to raw compaction. And of course it interacts with the media. So you have to cover that space, and we'd be helpful to know what we fit in the past, so we know we're no longer hitting it. But things like the sharded RocksDB and maybe even TRocksDB and other things, but there seem to be a lot of reasons to believe at a theoretical level that sharded RocksDB is super helpful. At least I expect it due to the isolation, because apparently it isolates pglog, pginfo.
I think we're going to have to rely on the sharding more than TRocksDB. It sounds like, just because it's going to be hard. The RocksDB guys haven't shown a whole lot of interest in upstreaming it, so the sharded stuff is probably the way we're going to rely on for the short term.
We have to know we certainly want to know what it does, and I don't know if you have a clear impression of that right now. My understanding is that it helped. This is more of a downstream. I don't know, maybe it's an upstream thing too. I mean, to the extent we're going to rely on things like RocksDB as building blocks, we need them to be taking it as seriously as we do. Their lack of interest in performance doesn't speak well.
I think they've got BlobDB and RocksDB, which is kind of a similar idea to TRocksDB. It's not quite as mature as TRocksDB is, I think. So I think there's just some competing ideas about how to implement some of these things, right? But we'll see. From our perspective, though, I guess it means just that we're going to have to short term anyway.
But I'd like to see us even as an upstream team. Understand exactly what we're paying for. I think in terms of like T-Rocks, I'd like to understand what the available. I'd like to understand more clearly than I've seen so far what the available benefit is. If it's very large, if it's not very large, or if it's very how big. An opportunity is it? Especially if it's not that great, especially after sharding, then no one cares.
It's not going to be real easy to determine because it's based on the ratio of the key size to the value size, right? So if we have like giant keys and tiny values, then it's going to be like not useful at all. It's not going to help a lot. But if we have lots of big values and tiny keys, then it's like super helpful.
Let's take a look, and maybe we can talk about that in future discussions. But in terms of the benchmarking you're doing, in terms of more naturalistic, from my team's perspective, more naturalistic S3 workloads, perhaps ones based on Hadoop Spark.
Yeah, I don't know if you guys know. I have no idea what typical key sizes are for people that or if there even is typical key sizes for real data going into S3. Like if it's just all over the place, or if it's tends to be within.
In all the universe of things that you can do with it, yes. But we can look at specific workloads, like we could do an example would be we could do TPCGS on Spark SQL or on Spark rather, and then we could then just analyze it and take it as a baseline.
Yeah, key size is really a problem in a lot of ways, though, right? Because it hurts us for pglog. It hurts us in terms of what kind of write amplification we'll see space amplification we'll see. Well, I was right the first time. Write amplification we'll see in terms of like TRocksDB, how much it can help.
Understood. So yeah, you make a good point. I understand. I see what you're saying. So if the workload doesn't have a significant contribution from the values, then line them as harmless and sign out.
It's something this is something we have to, I think, be really aware of, is that key size is really, I think, going to be a really important factor in terms of how well we can do, especially as we move towards like really fast devices like this. Well, anyway, so that's all I've got, guys. So far, anyway. Hopefully, I'll have bucket listing tests next week. We can see what those look like too. Anything else that folks would like to talk about today? All right. Well, it's been lively discussion. Thanks for coming. I appreciate it. See you next week.